Hi, thank you for clicking on this video. My name is Chrissy and I make both teaching and gardening videos. The gardening videos are a little bit newer but are near and dear to my heart. This video is, as you can tell by the title, a teaching video. I wanted to share with you all this lab that I do for plate tectonics. So for this lab, what we're going to do is we're going to follow the footsteps of Marie Tharp. She's the woman that's credited for mapping the ocean floor. Fun fact, she was not allowed on the boats. She had to stay behind because only men were on the boats. So she did work with someone else who gave her the data, and then she hand sketched the ocean floor, which is quite crazy. So while my students don't have to hand sketch the ocean floor, they are going to be using Google Earth and Google Sheets to do approximately the same thing. And I wanted to share with you how I'm going to do this. The first thing that we're going to do is open Google Earth. And the first step, it says to click on New Project when prompted and name your new project, Mapping the Ocean Floor. Feel free to have them do whatever else they want. That's fine. So I'm going to click New, which is on the top left, and New Project. And it already has some of my old stuff. To change the title, you're just going to double click up here. And I think I said Mapping the Ocean Floor _ your name. All right. Then the second step is to create the grid view like you see here. So what you're going to do is you're going to click on View and select, and select Show Grid Lines. They might already have that in their Google Earth if they've used Google Earth before. So again, under View, if they have clicked it, it'll say Hide Grid Lines. If they have not used Google Earth before, it'll look like this, and you have to click Show Grid Lines. That's going to display your latitude and longitude coordinates. Notice if you zoom out, by the way, your interval between coordinates becomes a lot greater. Here we have about 10 degrees per latitude lines and 10 degrees per longitude lines as well. And if you zoom in, of course, you're gonna have a smaller interval because it's a smaller area and you can get more precise readings. So that might be helpful if your students maybe aren't quite getting where they're supposed to be. So then what I'd like them to do is shift the screen towards the East Coast as mentioned in line 4. And this is just going to help orient them because they do need to map out the whole Atlantic Ocean between the Americas and the African coastline. They can theoretically start wherever they want to, but we are going to map out from the coastline of the Americas to the coastline of the African continent. So again, I am zoomed in on the East Coast. Then what we're going to do is continue zooming in on the East Coast until we see a depth or elevation reader on the bottom, should be bottom right of the toolbar. So notice here, I am zoomed out pretty far. Again, my interval between longitude lines and latitude lines are about 10 degrees. What I'm seeing on the bottom are those coordinates, and they're moving because my cursor is moving. So wherever my cursor is, that's what the data is going to display. If I zoom in, I gotta zoom in a little bit more, do a little bit more. Not yet. Oh, okay. If I zoom in all the way on the bottom in that toolbar, the rightmost section, there is this number. Currently it says -196 m, which stands for 196 meters below sea level. If you see a positive sign or just no negative, then it would be above sea level. So again, it follows your cursor, so that is going to be annoying. As far as I've found, there's no way to pause this. You do just have to make sure that you leave your cursor where it is to get that, that depth for these different areas, which I'll show. So next, what I tell the students is, hey, we're gonna create a topographic profile, so that side view of what the ocean floor looks like. And specifically, we're going to follow a constant line, a constant latitude line, just so that way your depth readings have a little bit more consistency. You're not like going north or going south, you're just following that latitude line straight across. I'm going to be practicing on the 35 degrees north line. They can do whichever one they want. So I'm gonna follow 35 degrees north. I'm zoomed in enough to where I can see the depth reader on the bottom. And now what I'm going to do, as it says in step 7, in the menu bar, I'm going to click the ruler, and that ruler stands for the measuring distance and area tool. And this is going to allow me to gather the distance from point A to point B. I'm gonna have point A be the coastline, and my point B for my class is going to be 100 kilometers. If you would like to make this lab a bit shorter, then what I would recommend is to have your point B be even further, maybe 500 kilometers or 1,000 kilometers, whatever interval you would like. That's just going to make the lab shorter because they don't have to take so many different points of data. So let me show you how to do this. In Google Earth, there's this ruler in the menu. It's called distance, or measure distance and area. You're gonna click it, then find the coastline for your chosen latitude. This is, can I scroll up a little? I'll scroll down just so that way you can see the 35 north a bit better. So I'm gonna start my point A at the coastline. I'm going to follow the 35 north line as best as I can. And about 100 kilometers away, I'm gonna place a marker, and that's going to be my point B. I really recommend you letting the kids know you don't have to be super accurate with this. Try to get to around 100 kilometers or whatever your chosen interval is, but they don't have to be nitpicky and get to 100.00 kilometers. That's not what we're looking for. We're just looking for an estimate. So I place my point B marker. My line is 107 kilometers away, and I'm going to look down to my depth reader, and it says my depth is 2,330 meters below sea level. That negative just means below sea level, so they should include that in their spreadsheet, which I'll get to in just a second, because that'll help them more accurately display what's going on. That is something to note too. If their profile doesn't look like what it should, it might be because they left out those negatives in there. I do want to point out though, if they try to move their cursor somewhere else, again, their cursor is going to change what the depth reader is showing, because the depth reader and the really all of these numbers on the bottom, latitude and longitude coordinates, they're all going to change with wherever your cursor is. So that's why I like to place that point B dot, because if I move my cursor, I can always just go back to it like a home base and read what that number is. It might be just a little bit different. I forget what I said before. I think this number is just slightly different, but again, it doesn't change the overall trajectory of what our map should look like. So now that I've placed my point B, I'm gonna keep going doing this with the measure tool, the measure distance and area. I'm gonna keep doing this for my interval of 100 kilometers. So now that I'm at 107 kilometers, I'm gonna go to 200 or somewhere, 203. Perfect, place my dot. I'm now at 3,604 meters below sea level. And I go on and on and on, 300 and so on. Do this all the way until you get to the African coastline. So where they're gonna place this information, so they're gonna go into the Google Sheet. Let me delete some of this, oops. Okay, so they're going to go into the Google Sheet, and this is where they're going to put down the information that they've recorded. So -2,000, -3,000, so on and so forth, until they have measured out all the way 6,500 kilometers, or however long it takes them to get to the coastline. Since the coastline on both continents are very different, you might need to expand this data point a little bit more. To expand the data, you don't have to write in a whole bunch of numbers. I've made a rule starting on A3 that every box will be equal to what's above it plus my interval of 100. So if I wanted to expand this, because maybe my coastline, or my distance between coastlines, the Africas and the Americas, if it's greater than 6,500 kilometers, then because I have that rule in place where it's equal to the cell above it plus 100, I can just, using this circle, I can click it and drag it down and it'll display those numbers for me. That's a really easy way for you to save time as a teacher because we have a lot going on. Similarly, if you would like to change the interval for your students, maybe you don't have as much time, maybe you would like your students to hand graph this. I won't be, I'll be showing you what I'm doing in a second, and you don't want them to hand graph, 67 points of data, or maybe you have SPED students that need some accommodation and they need chunking or just smaller bits and pieces. Either way, you want to change the interval. You don't have to go through and do this all by hand. Again, change that rule, which is in cell A3. What the rule will be is it'll be equal to the cell above it, A2. We're starting at 0 because this is our distance between coastlines, plus whatever your interval is. If you want to do an interval of 500, then delete that 100 and put 500 equal. Now, when I use that circle and drag down, it'll change that data. It's following the rule that I've set. So you shouldn't need to go this far down. I would say around 6,500, maybe a little bit more, again, depending on what your latitude is and what the distance is between the coastlines. But either way, that's one way to change it for your students, so that way your lab maybe takes less time, maybe takes more time if you want to shrink that interval, or whatever the case is. I'm just gonna bring it back to what I had before, and there you go. So again, they're gonna continue placing those plot points. The second thing that I wanted to bring up is I would recommend allowing your students to do this with a partner. Sometimes I don't allow that because I find that maybe one student is not doing the work and another one is doing it all. But this is one of those cases where both students have a job, and so they should both be doing something. So one student might have their computer on the Google Sheet and will be the recorder, and so they're recording down all the information. The other student is the one that is doing the measuring through Google Earth. Kind of like how Marie Tharp and I forget the other gentleman's name, I should know this, but kind of like how they did it where she wasn't allowed on the boat, he was, so he was the one actually gathering the data and she was the one implementing the data. So you can have it where your students are paired up, and that makes it go a little bit faster because the one student on Google Earth can read out the value and the other student can write it down. Can write it down, and then it's not so time consuming having to go back through the pages, because I know I get very frustrated when I have to go through my different tabs. Once they do have, it looks like I have 2 of these open. Once they do have all their data recorded, I'm just gonna give some random numbers real quick. I would also recommend this too, just put some random numbers in your cells. I find that if I try to replicate if I try to make the data look accurate, they might try to replicate it. So I'm just trying to make it so that way they can't do that. So I plug in some random numbers. What they're gonna do, which is explained in part 2, creating the graph, is they're going to highlight cell A and cell B. You do this by simply clicking and dragging. Just because I don't have all of cell B filled in, I'm gonna click and drag. Once they have those columns highlighted, what they're gonna do is they're gonna go over to this picture, which is called Insert Chart. It looks like a bar chart. They could also, if they wanted to, in the drop-down menu, click Insert and then click Chart as well. It works the same way. I just like the picture. And it will automatically populate a graph for you. So my values were all over the place. This is not what it's gonna look like for the kids, but because obviously I made up my own data. but it populates it very quickly. If you want them to hand graph it, that's completely fine. Tailor this lesson to meet your needs. I would maybe recommend, though, fewer data points, so maybe making that interval between data points a lot bigger, but however you want to do it. Then have them copy the link, and they're going to paste the link in this red section. So you'll have access to the data and the chart. And then the very last thing that they have to do are some conclusion questions. Hey everyone, so I ran through the activity with my students today, and I am happy to say that it went really, really well. So I had kids, especially if they were paired together, I had them finish in about 45 minutes, maybe an hour, I would say, for the pairs. And then anyone that wasn't paired up, they chose to do it by themselves. They finished in, I would say, just a little over an hour, and some of them had to take the whole block. The kids were able to understand what the graph is trying to show, and I'll post a picture of one of my students' graphs here. I can clearly see the mid-ocean ridge here, followed by smaller and smaller mountains, and they were able to pick up on that as well. So it ended up working really well. I was very pleased with it. If you end up doing this activity, I would love for you to come back to this video and comment your successes and your failures, your comments and any questions that you have. I really just want this to be a place where we can be a community and support each other. So anything that you think is helpful that you'd like to add, please do so below. Yeah, that's pretty much it. Thank you for clicking on this video, and I hope to see you in the next one. Bye.